Hello, we're at the European Offshore Conference in London and we're talking to Sonke Sigfridsson, the founder of Aerodyn Engineering, which is displaying a radical new offshore turbine at the show.
I think the offshore market is asking for larger turbines, larger than 10 megawatt. You see it everywhere at the moment. And due to our experience, we don't think that a single turbine with a larger installed capacities than 10 megawatt will be really advantage in the cost of energy. So after our design work for Nessie, we are coming to the idea to put two turbines, smaller turbines that are already developed and also with practical experience on one floater, and so to save money with a floater because two turbines are much more lightweight than the larger one, and also the distance of the nacelle to the surface of the water is also lower, so that the whole floating system can be much less. So we see for the floating foundation that two turbines on it with the Nessie concept is a much more cost-effective solution than to have one big turbine. With the Nessie concept, I think there is a first time a design of an integrated system where we put into account the turbine and the floater together. So the turbine is optimized for the floating system and the other way around. So there is not only a floater where you put a turbine on it. So we see big advantages in this concept. When we are compared with the bottom fixed turbines, of course you can make the complete assembly and commissioning in the harbor and then pull it out to the site with much smaller tugboats than you need for the erection of bottom fixed turbines. You can see it everywhere around. Big ships, very expensive ships are necessary to bring the foundation in the ground, to make the erection and the final assembly. So that will save a lot of costs. We have implemented calculation software, and as a second step we have made some tests in the water tank in Cork in Ireland, where we have made the comparison between our calculation and the real wave situation in the water tank. So that was one big part. And since 1 year I'm working with a small group of very specialized engineers on this two-headed twin Nessie type, and that is of course a little bit more complicated because we have two turbines interacting to each other. So it was necessary to make a lot of CFD calculations of the interaction between the rotors and also in the water. And I think we are now here because we believe this system can be built and all the problems we have solved. So after this show, this model will go to a water tank, so that we make some additional tests with the thrusters on it to see how is the reaction in the water. Next we are planning a 1-to-6 model that we can put outside in real conditions, hopefully in Ireland. We are just on a good way to that. So with this turbine it will be a real function with two turbines on it, 1-to-6 scale. And we are just working together with some universities in Japan and some companies for making further evaluation on our Nessie concept. And I think the final report will be there at the end of this year, and we hope that we can get also a demonstration project in Japan. And so we hope from our side we can have a prototype in the water in 2 years. But we must also find some companies who are interested in this technology to make some co-financing.